This section examines liquid cooling systems in petrol and diesel engines. In this very basic liquid cooling system, a coolant is stored in a radiator and in the engine. As the engine heats up, a natural circulation starts as coolant rises through the engine block by convection. It passes through the top hose and into the radiator. Inside the radiator, heat is removed from the coolant as it falls from the top to the bottom. When it reaches the bottom, it returns to the engine through the lower radiator hose. This process is called thermosiphon. It was common in older cars which had low-powered engines and high, narrow radiators. In modern cars, the engines are more powerful and radiators are low and wide, and a thermosiphon process couldn't move the coolant quickly enough. Instead, a water pump forces it through passages called water jackets in the engine block. It collects heat and becomes hot itself. Heated coolant then returns to the radiator for cooling. And the cycle is repeated. Heat is removed from the engine and dispersed. Preventing overheating is one function of the cooling system. It also helps the engine reach its best operating temperature as soon as possible. Every engine has a temperature at which it operates best. Below this temperature, ignition and combustion can be difficult. Most engine wear occurs during this warm-up period, and most pollution too. One function of the thermostat is to shorten the warming up period. It operates according to coolant temperature. When coolant is cold, it is closed. When a cold engine starts, coolant circulates within the engine block and cylinder head and through a coolant bypass to the water pump inlet. It can't get to the radiator. As the engine warms up, the coolant trapped in the engine gets hotter and hotter. This starts to open the thermostat, allowing hot coolant to flow to the radiator. Many radiators are mounted at the front of the vehicle in the path of greatest airflow. The air carries heat away, cooling the liquid before it returns to absorb more heat from the engine. Where a radiator is mounted also depends on space, how the engine is mounted. A header tank can be mounted away from the radiator, where it provides a coolant supply stored above the engine. It can be made of sheet metal or hardened plastic. The radiator has two tanks and a core. The materials used in the radiator must be good heat conductors like brass or copper. Brass and copper are often used for tanks combined with a copper core. Modern vehicles often use plastic tanks combined with an aluminium core. This saves weight but still provides good heat transfer. The core consists of a number of tubes that carry coolant between the two tanks. The tubes can be in a vertical downflow pattern or a horizontal crossflow pattern. A crossflow radiator fits more easily under a steeply sloped bonnet. In the core, small, thin cooling fins are in contact with the tubes. The shape of the fins increases the surface area exposed to the air. Where coolant touches tube walls and where the tubes touch the fins, heat is removed from the coolant by conduction, then by radiation and convection at the surface of the fins. Air rushing by carries the heat away. Liquid emerges cooler at the bottom of the radiator. It travels through the lower radiator hose to the water pump inlet, then through the engine again. Coolant is transferred throughout the cooling system by hoses. Most vehicles have the engine mounted on flexible mountings to reduce noise and vibration. Since the radiator is mounted to the vehicle body, flexible hoses are needed. Coolant is also carried to the heating system, which is usually inside the cabin of the vehicle. Coolant hoses vary in diameter depending on the volume of coolant that passes through them. Heater hoses carry a smaller volume. Most hoses are made of rubber, and since they are subject to pressure, they are reinforced with a layer of fabric. They are moulded to a special shape to suit the model and make of vehicle. Some heater coolant hoses also have special shapes. All hoses are subject to hot coolant and high underbonnet temperatures, and they can deteriorate and fail.